All right, here we go. Chapter 6. So first of all, obviously here 6.1 is called discrete and continuous random variables. Discrete means like whole numbers or at least not repeating decimals. For example, 1.5, but mostly it's going to be like whole numbers versus things that can be any partial part of any number. So this one's talking about languages or AP score. We have an average of 3.7, but we cannot get a 3.7. So that's discrete, and continuous would be like time could be in any portion of seconds you wanted to measure it to. All right, so first of all here, we have our first example. It says we're selecting a US, and I'm gonna, for context purposes, US high school student at random. X is the number of languages spoken. They've defined the variable in the problem. That's not going to happen very often, but we at least do it to start here. Or once in a while, but we're going to have to get better about defining variables real quick here. All right, and then they give us the table plus the values, the probability model. Remember, that's what they call that when it gives the numbers and all of the probabilities. And then here we go. So it says, show that the probability distribution is legitimate. And then remember, we have to show both that for each probability, the probability, oh, and I see I need to fix this. It's not going to be fixed on the scan, but that's all right. For each individual probability, they're between 0 and 1 inclusive. And you have to include, even though none of these are 0 or 1, the rule is, remember, we're not really proving anything. We're just saying these are the rules. And that they each have to be between 0 and 1, and they can be defined as anything in that range, including 0 and 1. And then all of them together add up to be 1. So both of them. Everybody remembers this, not so much here. Okay, then the histogram. We won't be having you draw histograms on anything that's graded here, but here here we go. You can, just to give you a nice visual. Also, I always want to take the opportunity to remind you to label. Okay, remember, this is the scale, this is labeling and labeling. Don't forget that. I'm going to continue to say that as many times as possible. All right, so there's the histogram. And then again, we can see that it's definitely skewed to the right. There's something else we might talk about, but that's just a little bit of one SPOW review. Okay, next one, it says, what is the probability that a randomly selected student speaks at least 3 languages? Oh, sorry, at least 3 languages or more than 3 languages. So at least means you include 3, more than means you don't include 3. And again, all we're gonna do is look right here is there's at least 3, those 3 numbers added together. More than 3, these 2. But again, you're gonna go ahead, we need to get used to writing this up properly. And I told you they already had X defined, but we need to get used to writing it. It's notes, so I just went ahead and did it. So X is the number of languages spoken by U.S. student in the United States. So make sure you get that written out correctly. And then remember our probability statement, and you wouldn't write this, I just wrote this here for the notes, but the probability that X is at least 3, and you just add those, put those 3 numbers together and add them. And remember, this is showing your work, and then don't forget to give the units. And then, of course, just the other 2 numbers for more than 3. All right, next. Next talks about, the textbook uses a few gambling things. I hope nobody takes offense to that, but they're really good problems. And also, if anything, I can assure you they make you less interested in gambling. So it's okay. We just talk about it purely as a numbers situation here. All right, but when you, the game of roulette is the one with the numbers, and you put the numbers on the chips, and the numbers are either red or black, and then there's 2 green ones, a 0 and a double 0. So they get into the bets, okay, and then you can bet it right on the number, and you get more money. I think it's 35 to 1, or you can bet 2 numbers, and then it's like 17, or you can put it on a corner, and you get 4 numbers. Now, again, every time you get more numbers, the odds pay off less. But that's what a corner bet is. So you put the bet on a corner, you get 4 numbers, you have 4 possibilities to win when they spin the wheel and it lands in a number. And the game again is called roulette. If you have no idea what it is, you can pause it now and go Google it to at least see what we're talking about. All right. So right here, then they tell us that the distribution is right here. So if you place a $1 bet, you win $8 if it's one of the 4 winners. You lose $1 if it's one of the 34 non-winners. So you don't even really need to know what roulette is there if you have this value here. And again, they'll give us stuff where this doesn't make any sense to us, boring stuff. Sometimes it's cell phone stuff, and sometimes it's about the ratio of some gear on a train that we just don't worry about. All right, so anyway, it says a player is to make a $1 bet over time. What would be their average gain? So they want to know what's the average gain. So what you do is you take the probability that the event happens times that number, because we're talking about a weighted dollar bet. And you can plug that in and you get negative 5 cents. So the average net gain from a single corner bet is a 5 cent. If we're talking about the player, this one says player. So we would say a 5 cent loss for the player. If this had talked about the casino or the house's gain, then you would talk about it being a 5 cent win for the house. Even though it says negative here, this is from the player's point of view. So we would ignore this. I just want to keep that in there and mention that. If they were if it was asked from the point of view of the house. But anyway, and just I'm gonna get ahead of myself, and then we'll just go through the notes and then we'll talk about it. All right, so then this equation, when I see this is very, very complicated, but that's what's happening here. It's actually x1 times the probability of event 1, and then x2 times the probability of 2, and so on and so on and so on. This one had 2, usually there's like 3 or 4, whatever. This one only had 2. Okay, so mu of x, the average of the x's, is the expected value of x, and we have that here. They will use one or the other. They also might call it a weighted average. So again, we got all 3 of those mentioned in the notes here, try to make it a little bit easier. But that equation, I don't know. That equation, if you know what you're doing, the equation helps you remember. But if you don't know what you're doing, if you don't understand this process, this equation does not help you. So just words of advice there to be careful about. All right, then the next one, how do you interpret? Definitely interpret. What a surprise here, right? So here we go. If we randomly select a large number or many of blank, the average number of blank will be about whatever the expected value is. And again, then we will do some practice ones here in just a second. But if we had, I don't know, if I went back up and I went back and did this one here for the corner bets. So it'd be if I randomly selected many corner bets or a large number of corner bets, the average, and again, the average number of whatever, I would say the average player gain, or I would say the average player loss would be about 5 cents. So you'd say loss here, and then you would just say 5 cents here. Okay, and again, and with this negative, you might go ahead and say it as a gain would be about negative, but remember, they don't really like that. So you would say loss here and 5 cents. Okay, so if we did a whole bunch of them, if we did a ton of them, remember, not in the short game, like the coin flipping example, not in the short, but in the long run, the house wins or the player loses 5 cents on every one of those bets. And literally millions of those bets are made. So eventually, the house always gets to this number after enough bets have been made. Okay, this next one says, calculate and interpret the mean random variable for the language spoken example. So calculate it and interpret it. So this one, I've written it all out. We're going to show you later how you don't have to write all of these out. But this one had 5 of them. Certainly on the AP exam, I would write it all. But one language times the probability of that language. The second thing times its probability. The third thing times, again, remember we talked about this. If you know what this means, it helps a little bit, but no. So you just multiply all those and then you get the average. Now, if this was it, I would definitely want to put the units here, but that's going to get taken care of in my answer. So if it says interpret, you go, well, there's the number, and then now I'll interpret that number. But if we were to randomly select many U.S. high school students, the average numbers of language spoken would be about 1.457. And again, I don't have to put languages here because it's here. So it's not just you always have to put units next to the number, it's the context. So there you go. That's a very common problem. That's on the test. I'll just go ahead and let that out even on a video, but that you better be ready to do this. Maybe not even just this, but this for sure. All right, does the expected value of a random variable have to equal one of the possible values? Well, we just got 1.45, and 1.45 was not, well, that was the language example, sorry. 1.45 was not one of these numbers, okay? That's okay, it just doesn't have to. Then the question is, well, should you round? Okay, now if it's you get 1.99999 and you put 2, I think they're gonna be okay. If you take 1.45 and round it to 1 or 2, there's no way they're going to take that. And as a matter of fact, a lot of students, they think that they have to get one of these numbers, so they force the rounding to it, and the College Board wants to take off for that. So just don't round it to the nearest. They don't like it. They don't like it. All right. Next, standard deviation and variance. In a shocking turn of events, you're going to find the mean is easy, standard deviation is not. So here we go. So the variance is the standard deviation squared. Okay, and then again, we have this equation. I'm not going to talk about it much here. I'll show you with some numbers and it'll be better. But the equation is only helpful if you actually know what in the heck is going on. Otherwise, it looks like just a smearing of numbers and letters and in parentheses. But again, this little sigma x, that's standard deviation, and they'll do sigma squared for variance. Interpret standard deviation. Okay, I don't even need to read that. There's the mantra. You put in the context and actually give the number, and we'll have one here just in a minute. So next, we didn't talk about the red-black bet, but the red-black bet, what that one is on the game of roulette. You can bet the numbers 1 through 36 are either black or red, and you can bet a black or red, and it's a straight even money bet. If you bet $5 and you get the right color, then you get a 5. You get to keep your chip plus a $5. So it's a 1-to-1 bet. But if it lands on green, one of the 2 green ones, neither black or red, they both lose. So that's why this doesn't quite work out the same right here. You have 20 losers and 18 winners because you have those 2 extra, the 0 and the double zeros that are green. So basically what we're going to do here is just talk through the standard deviation equation. Now, and also we'll mention this, you can't actually add standard deviations. You always have to add the variance. So what this is doing is it changes it to the variance, and then it adds them, and then it square roots it together to get standard deviation. We're going to see that a whole bunch of times. But anyway, coming back up here, we take the value of the bet we either gained $1 or lost $1 or gained $1. Okay, so I said a $5. Of course, I said the wrong number, but a $1 bet, you would win $1 if you win, you lose $1 if you lose. That's just how that bet works. Okay, but again, there's a few more losers than there are winners. So again, the casino wins over time because every time that those bets are made and it lands on one of those greens, they win both of them. So anyway, you take the x1 minus, now in this one, when you do minus mu of x, notice how that's plus, and you're like, what gives with that? But don't forget, mu of x was negative 0.05. Trickery. So you actually add that, you square it, take it times the probability, just like we did this time. This one, you take the number, you subtract it from the average, you square it, multiply it by the probability. Take the second number, subtract it from the average, square it, take it times its probability. Not this one's probability, but this one here. All right, and then on both of these, we just had 2 of those. And then you'll just have to take my word for it. Those are the answers we get. And the corner bet has a higher standard deviation. This one, the payoff is either lose $1, gain $1. This one is lose $1 or gain 8. Okay, so there's a much bigger difference in the outcomes, therefore a larger standard deviation. use your calculator to calculate from the languages spoken. All right, so here I'm going to show you how to do the calculator, and I need to get that table back out real quick. So from this table, as you can see, I need to get my calculator ready. So I go stat edit, and I need to plug in these numbers. Oh, look at that. Look at how lucky I am. That was actually completely on accident. I'll be totally honest with you. But we go L1 and L2. L1 is the number of language spoken. L2 has to be the probability. You have to set it up like that. All right, then we're going to go stat. We're going to go over to calculate, and we're going to do 1-bar stats, just like we did. That was like the very first thing we ever did on this calculator was 1-bar stats. And again, I have this already set up. This is always L1. We've never changed that. We've just gone down to calculate and hit enter. Well, now there's something else. We need to get this L2 here. So to get L2, I would slide down. Again, yours would be blank. Mine says L2. I'll tell you what. We'll get rid of it so we don't have to. To get that L2 on there, you hit second and then the 2 button. And you'll get that L2. The frequency. So the list is what are the values. This is the frequency for which they happen. 63%, 29.5%, etc. And then this looks a little bit different to us. We don't really care about the Q1 or the minimum. That's of no consequence. We want this number right here. So see that? There's the mean. The calculator could have told us that. We didn't need to type in all the, I mean, it could tell us that by just putting the values. And there's my standard deviation. Okay, that's a skill we want to have. I guess for now you can write it. You could open notes. You could write down how to do it, but you need to be able to do that later without it being open notes. And then again, to get this the variance, we would take this number right here and we square it to get the variance. Are there any dangers to using the calculator? And again, you must show work. You must actually write down everything you put. And so like that's for this. So like this, we're going to do this one on the calculator, but then this is what you would actually write out. And again, later we'll show you, I think, not on this one. I guess in the past we've made the students suffer for one day, but later we'll show you how you won't have to write out all 5 of these steps, but I guess that's going to have to wait for the next video. But anyway, so you must still show you where you must still write this stuff down, or at least the abbreviated one you'll learn next time. Let's go ahead and do this problem as well. And so I got all this other stuff. We'll clear that out in just a minute. So I go stat edit. This time my values are 0, 1, 2, and 3. And I need to get rid of that last one. I just hit delete. Don't hit delete where it says L1 or L2. Also this time, I'm going to be a little bit smarter and I'm going to clear it first. Clear and push down. And I put in the probability for each of those. Stat, calc, enter. Now again, this already has L2 there because I've already done this problem, but taking the AP exam, that probably won't be there. And I get 1.1 and 0.94, etc. Now, when I write out the work, I still write out 0 times 0.3, 1 times 0.4, etc. And later we'll find out I'll just spill the beans. You do 2 of them and you go plus dot dot dot, and the first 2 establish the pattern. Especially if this gets longer. If this is 4, I would probably just write out all 4 and just be done with it. But if it's like 5 or 6 of them or 7, it gets worse. And again, for standard deviation, you take the item minus the average we got here, 0 minus 1.1 squared times the probability. Okay, then it was 1 minus 1.1 minus 1.1 minus, see it? I'll see that. And again, you're still showing the work. Now, you probably didn't need this step in here, but I just did that. And there's the standard deviation. We get the numbers from the calculator. Okay, then we do what the College Board says we must. But we don't do it their way. We just write it down in the way that makes them happy and give us full credit. All right. Okay, the next thing, how many possible foot lengths on there? How do we graph the distribution of foot length? All right, so here we go. So what's it mean by infinitely many? if you took 1,000 people and you got a 3D model of their foot, you would find out that not a single one of those feet are the same. And if you got 1,000,000 of them, you're probably not going to get any of them that are the same. So when you talk about the size of a foot, that's what they mean by a continuous random variable. It can be any different number of ways to measure it and to explain it graphically, but none of them will be exactly the same. So the chances of getting 2 of them that are the same or exactly getting one exact measurement of a foot is exactly going to be equal to 0. That's what they're talking about, that one. So before we had discrete, right? It was 1 or 2 or 3 or 4. Now we're going to be doing things that are not necessarily discrete, that are going to be continuous random variables. All right, how do we find the probabilities of a continuous random variable? We use the z-score if they're normal. All right, so normal CDF. We're going to come back to see some more normal CDF stuff. All right, what are the 3-step process? State the distribution, but this one's not too bad if it's normal. Remember, we have a nice shortcut for a shorthand for that. Perform the calculation. Answer the question in a sentence with context. All right, then here's something. So let's just talk about that. I'm not going to worry about what we talk here. The probability, so if we talk about the foot, let's just say I want to find a foot that's exactly 8 inches long. The probability that I find a foot that's exactly 8 inches long is 0. So that means the probability of finding one that's less than 8 or less than or equal to 8 is exactly the same thing. Because in a continuous random variable, the probability of getting one value is 0, or so small to 0, it's actually 1 over infinity, which we say is approximately 0, at least in this class. And you can get into that later in advanced calculus classes, but for right now, it's small enough that we say that it's equal to 0. But here's the kicker. This is why this is written here. You must write your probability statement correct. So if I say less than 8 and you say less than or equal to 8, you get half off. You're like, yeah, but it's the same. It's the same unless it's a technical writing class, like AP statistics. So be careful. And again, I understand. I would be frustrated if I was a student, but you'll have to also understand it doesn't matter. Half. That's what College Board does, half. So you have to still state it correctly in your probability statement, but you also need to know that they're the same. Okay, I think I over-explained that one, especially for a video. And then we have some write-up here. So we're going to go through this. So the weights of 3-year-old females closely follows a normal distribution with a mean of 30.7 pounds and a standard deviation of 3.6 pounds. So notice they just give us mean and standard deviation. Randomly choose one 3-year-old female and call her weight X. Find the probability that they weigh at least 30 pounds. Okay, so we define X. X is the weight of a randomly selected 30-year-old female. And we got to get really good at doing that. We're going to get, and the deal is, if you forget that, they deduct your grade from full credit to half or half to none. So you can't do that. All right. State X is normally distributed. And again, sometimes I'll get a little wordier here, but I don't take off if you just put this. I think the College Board's okay with that too. So remember, if we state this is normally distributed, mean, standard deviation, that's got its own special shorthand, and let's take advantage of it. Okay, do the calculations. The probability that X is greater than or equal to 30, at least 30, normal CDF. We got all the information. We get the answer, and then we conclude in context. About 57.7% of 3-year-old females will weigh at least 30 pounds. And a lot of that is you spitting back the question back for your last answer. Okay, define the variable. State the distribution. Do the calculation. Answer the friggin' question. Find the probability that a randomly selected 3-year-old female weighs between, okay, so we've done this before again. So that one, instead of, I said from 30 to 1,000 on this one. Yeah, I think 1,000 was well big enough. I better not be having no 1,000-pound 3-year-old females, or 3-year-old anybody's, not 3-year-old, that doesn't matter. Anyway, so then this one is between 25 and 30. Okay, and it's this one between, so some people actually had to look this one up. Is between, what do they mean? Does between mean it can include or not? Don't worry about it being that wishy-washy. But that one's going to be written this way. And if I was silly enough to put between, I would accept both of those. Even though after I just talked about how important it is you write it correctly, between is kind of a goofy one. But if they say between and you can remember it, they mean without the equal to. Okay, and then we put those in. Normal CDF, easy, easy. I don't think I need to go through all that. But again, that's just back on the calculator. And it is not an accident that normal CDF pops over from time to time. Could have done it all together, but they like to do that because that's something you'll definitely have to do multiple times. All right, now this one says that the probability x is less than k, it's equal to 0.8. So what's the value of k? And that's backwards, that's inverse norm. You give the area, and remember inverse norm always goes to the left, unless you have a brand new calculator, you can mess with that, but I wouldn't recommend it. Mu and sigma, again, don't forget you have to write all this out. No A for area, you have to write the word area. And that's one of the things they're very picky about. And then there's the number, and I just then gave it with the units on it.